Okay, assignment 37 is 5.5, the mean value theorem. A lot of times I will refer to the mean value theorem as MVT and Rolle's theorem. Okay, essential question. What are the MVT or mean value theorem and Rolle's theorems? And how do you find the point in an interval at which the instantaneous rate of change equals the average rate of change of a function? Question mark. So I gave you a handout in class for this lecture. This will kind of shorten our notes so that I can show you a video. So the first page is the mean value theorem. So basically you have two conditions that need to be true, and if these two conditions are true, then the mean value theorem will be true. So all the mean value theorem says is that, and I'm just going to go through each one of these individually, okay? So if you have a function f, which is differentiable for all values in the open interval a to b, okay? Meaning not necessarily including a and b, okay? So if I can take the derivative all along the function, okay, it's differentiable. Not necessarily at the end point, because that would be challenging because we don't have the point before it, so we don't actually know what that rate of change would be. The second condition is that f has to also be continuous for all values x in the closed interval ab, which means it needs to be continuous from a all the way to b, so including a and b. Okay, so if that's true, then what you're going to find is that there is going to be at least one number, x equals c, somewhere in that interval ab, such that the instantaneous rate, which is the derivative, f prime of c, is going to actually equal the average rate of change. Okay, so what does this actually mean? So I feel like it's a lot better to look at the picture. Okay, so here's my function f. And drawn to that function is this tangent line. And the slope of any tangent line will be the instantaneous velocity or the instantaneous rate of change. Okay, so this would be the tangent line. Okay, the slope is going to equal the instantaneous rate of change. Well, on any function with endpoints or any 2 points on any function, you can always draw a secant line, right? A secant line just connecting those 2 points, a and b. And then I get a linear function, and the slope of any linear function is going to be, hopefully you know this, right? The rise over the run, or the average rate of change, the average rate. Okay, so the slope here is the secant line. And all this is saying is that if these two conditions are met, it's differentiable on that interval, it's continuous on that interval, then there will be some point, we'll call that x equals c, where the slope of the tangent line will equal the slope of the secant line, or the average velocity will equal the instantaneous velocity, or the derivative will equal the slope. Okay, so that's really, really, really simple. The other one that we are going to go over is Rolle's theorem. So Rolle's theorem is actually even easier as a concept. So here you have 3 conditions that must be met. So once again, f must be differentiable for all x values in the open interval. It must be continuous for all x values in the closed interval. And there's one more condition here. The output at A, the output of B need to equal 0. Okay, so at A, you're going to start at 0. At B, you're also going to be at 0. Okay, and then this becomes really obvious. So if I started at 0, and I went up and I came back and I ended at 0, well, then there must be somewhere within that A to B interval where I can find an x value like C, where the derivative or the slope of the tangent line will equal 0, right? Because that basically means if A is 0, if f of A is 0 and f of B is 0, that basically means that there's going to be a maximum or a minimum in between there somewhere. And so anytime you have a max or a min, you know that the derivative of the tangent line at that max or that min is 0. Okay, so that's all that that's saying. So then there's going to be at least one number, x equals c, in that interval such that the derivative is equal to 0. And that's Rolle's theorem. I'm going to do 2 examples with you. They're both out of your book from page 217. And the first one we're going to do is number 6. All right, so here's the directions. Let's see if I can show it to you. For problems 3 to 6, plot the graph, find a point x equals c in the given interval at which the mean value theorem conclusion is true. Plot the secant line and the tangent line showing that they really are parallel. Sketch the resulting graphs. And we're going to do number 6. All right, so we're going to have h of x equals 5 minus the square root of x. And we're doing this on the closed interval 1 to 9. For me, I'm going to rewrite this. I'd like to see this as being x to the 1/2. So I'll do negative x to the 1/2 plus 5. Okay, so thinking about this graph, first thing I want to do is see what the graph looks like. Now it's a square root graph, and it's negative, so it's flipped, and it's raised up 5. And I care about it from 1 to 9. All right, this should actually be h of x. Okay, so when I plug 1 in, I'm going to have, that's basically just going to give me negative 1 plus 5, so that's going to be 4. And when I plug 9 in, let's see, the square root of 9, that's going to be 3, so negative 3 plus 5, so I'm going to end up with 2. So again, this is going to be, originally it's this graph, but now it's flipped upside down, and then it's also raised up 5. So it'll look something like this. Okay, so let's see, let's go back to the directions. We want to plot the graph. We want to figure out where the mean value theorem is true. We're going to plot the secant line and tangent line showing that they really are parallel, and then sketch the resulting graphs. Okay. So if I had a secant line, it would look something like that. And I'm looking for where, and I don't really know where this is yet, but I'm looking for where the tangent line is going to be parallel. So I think I've done a pretty good job drawing that. So the thing that I want to do is I want to figure out, well, what is the slope of the secant line and what is the slope of the tangent line? Okay, so that's really what I'm looking for, is where h prime of c is equal to, well, the slope. So h of b minus h of a all over b minus a. Or again, that's the, right here we've got slope of tangent line or the instantaneous rate. And then over here we've got the slope of the secant line. or the average rate of change. We're looking for where those are equal. Okay, so I think it might be pretty important then for me to figure out what the derivative is, and then for me to also figure out the slope here. Okay, so let's see, going off to the side, h prime of x. We'll back up to my original here. I'm going to have to bring down that 1/2, so it's going to be negative 1/2 x to the negative 1/2. Okay, and then the other thing that I need is h of b minus h of a over b minus a. So h of b is 2 minus, let's see, 4 all over 9 minus 1. So this is going to give me negative 2 over 8 or negative 1/4. Okay, so I'm going to set those equal to each other. Oops. Okay, and then I'm going to go ahead and I'm going to solve for x. So it might be best if I got rid of this negative 1/2 first. So I'll multiply both sides by negative 2. And that's just going to end up giving me 1/2. Okay, and then I'm going to want to turn this just into x. So I'll multiply, or I'll raise both sides to the negative 2. So this side just becomes x. This side, well, it's going to flip, and I'm going to square it, so x equals 4. So let's see how accurate my graph is. Well, I was a little bit off. 1, 2, 3, 4. Okay, so really, it should be drawn here, the tangent line, to make it parallel. Okay? All right, so that was the mean value theorem. And then the other problem that I want to do with you has to do with Rolle's theorem. And we'll do number 8. So this just says for problems 7 through 10, we're going to plot the graph. Then we're going to find an interval in which the hypothesis of Rolle's theorem are met. Then we're going to find this point, x equals c, in that interval at which the conclusion of Rolle's theorem is true. We'll plot a horizontal line through that point and show that the line really is tangent to the graph, and then, of course, sketch the result. Okay? So first of all, we need to figure out the interval on which the hypothesis of Rolle's theorem is met. So that means that, that first input, or x value, needs to have an output that's 0, and the second x value also needs to have an output that's 0. Okay, so number 8 is f of x equals x squared times sine of x. Oops. All right, so we're looking for where this thing equals 0. What I see here is a couple of factors, right? There's multiplication happening here. So I want to figure out where x squared equals 0. And I also want to figure out where sine of x equals 0. So this could, there could be several intervals where this could occur. We're going to locate one of them. So it says find an interval where this happens. All right, so, well, for this one, x equals 0. Now, where does sine of x equal 0? So you can think about either the graph of sine, or you can also think about your unit circle. So I know that sine is going to be 0 here and here, right? So basically, sine is going to be 0 at 0 when x equals 0, or when x equals pi. So I know that my interval that I care about right now, and I could go, this repeats itself, but I'm just going to go ahead and use the one closest to the origin. I know that my interval then is going to be from 0 to pi. Okay? So So let's get a graph of what this thing looks like on that interval. Oops, gotta turn it on. Okay, so it's going to be something. I don't think there's a hump there now. Where this here will be 0, and this here is going to be pi. Okay, and we're looking for a place in the middle, so we're looking for what is this value here, where I can then draw a tangent line with a slope of 0. All right, so looks to me like the conditions are true, right? We're continuous, we're differentiable, and then we also have our endpoints that are both zeros. Okay, so the first thing that we did was we have already found our roots. Maybe I should write that out for you guys. So the first step is to find your roots. And now to find C, what I'm going to do, my second step here, is I'm going to actually find the derivative, set it equal to 0. All right, so f prime of x. Well, looks like I've got a product here. So the derivative of the first will be 2x times the second is sine x plus the first, which is x squared, times the derivative of the second, which is cosine x. I'm going to set that equal to 0. From here you have two options. One of them is to actually take this and go ahead and plug it in as your y1, or the other one is to actually go ahead and find the derivative using your numerical derivative here. So we haven't done this in a while, so we're going to go ahead and practice in case if you haven't been doing it. So to find the numerical derivative, we're just going to do math, and then n deriv, which is 8. Okay, and we're going to do that with respect to x. Now, in here, I want to do y1, so I'm going to use my vars. And I want y vars function. And I'm going to do y1. Okay, and then x equals x, because I'm not plugging in a certain value here. Okay, so, oops, graph that. So that's my first graph. Here comes the derivative graph. Okay, and it might be helpful, you know, to realize, like, some of you guys have color, and so it's easy to understand, but that was why it was kind of important that we graphed the first one that we had, so that we understood what that looked like, and now we have this graph of the derivative function. And what we're looking for on this derivative function is, where does it equal 0? So I see, and within our interval, within 0 to pi. So I see a 0 right here, so now I'm just going to calculate that. Okay, now I'm not on the correct graph, so I'm going to hit up or down, and that'll take me to the correct graph. This is the left side. I'll go to the right boundary, down there somewhere, and then I'll go to my best guess, about there. Oh, wait, what's happening? Stop moving. No. This calculator has a mind of its own. Okay. And I got, this thing will equal 0 when x is approximately 2.889 and so on. Okay, so that tells me that C right here is going to be approximately 2.889.